Application of logarithms. We have one application problem. It says the initial size of a bacteria is 500 mg and it doubles every 30 minutes. How long does it take the bacteria to reach 11,000 mg? So we consider our population model PT is P naught e to the RT, where P naught is the initial size, R is the rate of growth, and T is the time. So since in 30 minutes the size will be doubled, if initial is 500, then after T equals 30 minutes the size will be 1000. So then we can just write here 1000 equals 500 e to the R we don't know, but we know T is 30 minutes. Now we need to find R from here. So what we do, first we divide both sides by 500. So then you get 2 equals e to the 30 R. Now if you take the logarithm, then you get natural log of 2 is natural log of e to the 30 R. So that means natural log of 2 is 30 R. Natural log of e, and you know natural log of e is 1, so it is 30 R. And then what do we get? Our R equals natural log of 2 over 30. You can make it decimal or leave it there. Now we do the next part. In the next part we know that if size is 11,000 mg milligram, then what is my T? So then the model we have found, we can now write Pt equals 500 e to the T times natural log of 2 over 30. Now if my population is 11,000, just write here 11,000 equals 500 e to the T natural log of 2 over 30. Now you can simplify dividing both sides by 500. So you get 22 equals e to the T natural log of 2 over 30. Now further simplification, taking logarithm on both sides again will give us natural log of 22 equals T natural log of 2 over 30. So now when you are looking for T, so your T will be simply natural log of 22 times 30 over natural log of 2. Now you can take a calculator and simplify. 133.7829 minutes roughly. And we keep 4 decimal places because it did not mention how many decimal places to round it. So at least 4 decimal places I prefer. Thank you. We'll go to the next problem. Our next problem is the half-life of carbon-14 is 30 years. How long does it take if 80 mg to decay to 20 mg? Now it is a decay model, but still we can use our population model or the model of the culture or the size. Pt equals P naught e to the RT. This one say half-life of carbon is 30 years. That means if the population initial size is 100, then in 30 years it will be 50. That's the meaning of half-life is 30 years. So now in this problem we have the half-life of carbon-14 is 30 years. How long does it take if 80 mg to decay to 20 mg? So we can use the same population model. Pt equals P naught e to the RT. We have 80 mg decays to 20 mg. Let us assume 80 mg is our initial size. So then when T is 30 years, then the size will be half of it, so 40. So then we can just write 40 is equals 80 e to the 30 R, because T is 30. So we'll figure out R. Now divide both sides by 80. So then you are getting natural log of 1/2 equals 30 R. So then R will be natural log of 1/2 over 30. I don't want to round it, so I'll leave it here. Since it is natural log of 1/2 over 30, the answer automatically will come out as a negative. So let us keep this. Now they are saying that how long it will take 80 milligram to decay to 20 milligram. So that means now we'll have a 20 milligram in here, and this will be 80 milligram here, and e to the natural log of 1/2 over 30. This is my r, and we are looking for t now for 20 mg. Now if you divide both sides by 80, you get 1 over 4, which is, with a natural log, will give you natural log of 1/2 over 30 times t. And then it is the same way we are finding. I have natural log of 1/4 times 30 over natural log of 1/2. So we see that our final answer is 60 years. I have taken this example just to give you some flavor. You can easily understand that it is half-life. So then if I have 80 mg, it will be half, meaning is 40 mg in 30 years. So the another half, 40 to 20, will take another 30 years. So that should be 60 years. And that exactly we see here.